Hello, everyone. We're going to start now. So, welcome, everybody. We have this amazing panel today, this afternoon, on AI for social good. I'm very happy to present and to moderate this panel of amazing speakers. We're going to start by Jeff Dean. Jeff Dean joined Google in 1999 and is currently a Google Senior Fellow and SVP of Google AI and Health, overseeing Google's research and healthcare teams. He's a co-designer and co-implementer of many software systems, including several generations of Google query serving and advertising systems, among others, and the open source TensorFlow system for machine learning. Jeff received a PhD in computer science from the University of Washington in 1996 and a BS in computer science and economics from the University of Minnesota in 1990. He's a member of the US National Academy of Engineering and the American Academy of Art and Science, a fellow of the American Association for the Advancement of Science, and the winner of the ACM Prize in Computing and the Mark Weiser Award. So give a warm welcome to Jeff.
Thank you. All right. I'm really excited to be here. It's my first time in Uruguay, and I'm really just enjoying the weather and all the people here. Khipu is like this amazingly organized event. Thank you to the organizers. What I'm going to talk about is work by many, many people at Google. And really, it's work that I think is really important that we, as a research community, really be thinking about. Because a lot of the techniques that we're developing are sort of these amazing tools that can be used for so many different ways throughout society. And so there's like really amazing applications in healthcare and in things that will help us better protect the environment, or that can help people with different kinds of accessibility issues be able to perceive the world and communicate better. So I'm going to focus on just a few points just to give you a sense of the kinds of things that we're working on, but I hope in the panel discussion we have a broad-ranging discussion. So one is flood forecasting. So obviously, as the climate changes, floods are always a problem, but as the climate changes, there may be the potential of even more severe floods, and it's really important that we be able to understand where floods are likely to occur. And it's a big problem already today. There's like 250 million people around the world every year affected by floods, 18,000 fatalities, almost $10 billion in economic damages. But more the human cost, like you see people's homes and villages kind of washed away. So what can we do about it? And it turns out there's a field of sort of hydrology that is trying to understand the flow of water and to better understand how it's going to affect things as water levels rise. And so hydrology models basically are trying to understand this kind of flow to really understand which parts of the sort of landscape are going to be affected. And one of the challenges, one of the key inputs to these hydraulic models is elevation maps. And your hydraulic model is only as good as your elevation map. And the other point I want to make is that the landscape changes over time. So this is a picture of a river year by year as it changes its flow in a particular area where it's fairly low lying, and the river kind of makes its way in different ways year to year. And most of the hydrology maps are based on elevation maps that are fairly low resolution. They're based on satellite imagery of like 90 meter by 90 meter kind of squares and other kinds of things like that, which you see on the left. So there's a hydraulic model kind of being running. And you can see it's fairly coarse. Like you can't really tell at a fine-grained level which parts of a particular area are going to be affected. Whereas with a much higher resolution hydraulic model, you can actually really understand at a deep level, not just this village is going to be affected, but this part of this street is going to be affected. So our goal is to be able to have a much more accurate hydrologic model in order to understand flooding. And then, obviously, once we have that, we want to be able to understand and inform the public. So give actionable alerts, like you and your house are likely to be flooded in the next hour or the next week, next day maybe, at a fairly fine-grained level. And so that's one of the kind of areas we've been working on. We use sort of a combination of machine learning techniques to combine much higher resolution satellite imagery taken from multiple different angles at different times to really build much higher resolution elevation maps that then drives much more accurate flood prediction. And then once we have that, we have a bunch of different ways of getting alerts out to people. So we have our search interface, we have maps, and we have Android, which can send out sort of emergency alerts of a variety of different kinds when people are going to be affected. And that helps both local and public authorities communicate these messages. We've sent alerts to more than 2 billion people for hundreds of thousands of different events. And so that's one way I think machine learning through better hydrologic models can help us better understand flooding and really inform people in the way they want to be at the time that they most need that information. Okay. AI for healthcare, I think, is a super, super interesting topic. But I have another talk tomorrow, later today. So I'm going to talk about it mostly in there. I think there's great opportunities in areas, basically every medical imaging modality. Now that computer vision sort of works, we will have the ability to have really superhuman quality medical imaging diagnostics. There's really interesting work in use of medical records. How can you use that to make predictions about patients and so on? I'm not going to talk about that other than that overview. Another area that I think is interesting is the area of education. So we have a research project called BOLO, which is basically trying to develop new tools that use machine learning at their heart to help very early children learn to read more effectively. And so I'm going to give you a quick overview of BOLO. But the basic problem we're trying to tackle is that there's 600 million people who aren't achieving the minimum proficiency for both reading and mathematics that they should be according to their age. And that's a huge problem, right? Literacy literally drives many other things in sort of your future success. And being able to have a much better foundation on literacy will enable you to do many more things. And so BOLO is this application that's designed to help children in the age group of, say, 6 to 11, really learn to read more effectively. It's a reading buddy, so it's meant to be kind of engaging and really encourage people to read, and particularly to read aloud, so we can listen as the child reads and understand, are they saying what they're supposed to be saying? Are they pronouncing things correctly? Are they saying this word a little wrong? And both that can help them when we can understand what they're saying and their activity, and help them when they get stuck, but also give them encouragement for doing things well. And obviously, kids love to read lots of different kinds of things, and so having a library of lots of things that they can read is helpful. And if you gamify it a little, that's always fun. And so we've been doing early pilot tests last year with this application in a fairly rural part of India, near Lucknow in Uttar Pradesh. We did a 3-month sort of case control study of hundreds of students across many different villages, each of whom were sort of matched for the cases and the controls of families who had access to an Android phone that they could, in the control, they didn't get it, the software, and in the case, the treatment, we were basically giving them access to this application and then observing how kids used it and whether they improved in their reading. And what we saw was that roughly a 60% relative increase in reading level and efficacy of children who were given access to this application. And so rather than inundate you with more statistics, I'm going to play a nice little video that sort of shows the human impact on one family.
मेरा नाम नूतन है। सुंदर नगरी में मैं रहती हूँ। मैं बिंदी बनाती हूँ। मेरे 4 बेटी हैं। मैं तो अपनी लाइफ नहीं बना सकी, मैं तो बिंदी में रह गई। मेरे बच्चे पढ़ लेंगे तो अपनी लाइफ बना लेंगे। बच्चे पूछते मम्मी कैसे, ये क्या है? मैंने बेटा मैं पढ़ी नहीं हूँ, पढ़ी होती तो मैं ज़रूर बताती मैं आपको। मेरे बच्चे पढ़ नहीं पाते थे, शिकायत स्कूल में से बहुत आती थी, पर ट्यूशन भी नहीं पढ़ा पाते बच्चों को, किसी टाइम जो था पैसे नहीं होते घर के अंदर।
साझा एनजीओ से आए हैं।
और ये अनुराधा दीदी है ना, वो एनजीओ में जो काम करती है, ये घर घर पूछ रही थी आके, बोल रही थी ये ना एक ऐप है जो मोबाइल में डाउनलोड करोगे ना तो इसमें ना बच्चों को बिना नेट के पढ़ाया जाएगा।
तब मुझे नीचे जाना ही पड़ता है। अब तुम पढ़कर सुनाओ।
तब मुझे नीचे जाना भी पड़ता है।
शाबाश।
मेरे बच्चे भी पढ़े तो बहुत खुश हुए, मम्मी जी तो बिना पैसों के भी पढ़ाई हो रही है इसके अंदर।
मैं जल्दी घर जाना चाहती हूँ।
बहुत बढ़िया।
मुश्किलें हार गई जब बेटियों ने दी चुनौती।
तो जब से बोलो ये जो शुरू कराए तो मेरे बच्चे अच्छा पढ़ रहे हैं, मेरे बच्चों का आत्मविश्वास बढ़ चुका है। मम्मी हम भी तुम्हें कुछ बन के दिखाएंगे।
छोटे से बड़ी भौतिक इकाई।
कुमकुम मेरी डॉक्टर बनना चाहती है, छवि मेरी पुलिस बनना चाहती है। मेरे बच्चे कुछ कर लें तो उससे अच्छी बात क्या है।
The other thing that we realize is that there's lots and lots of organizations around the world that see potential problems and ways that machine learning could be used to improve those problems. And so last year we ran what we called the Google AI Impact Challenge, where we had people from all around the world submit applications of things they wanted to work on to apply for relatively large grants. So we gave about 20 organizations $1 million grants, roughly, each. To pursue, using these kinds of approaches. And so we got applications from many, many places, of course. And when we ended up selecting the 20 finalists, it was really great to see that they were doing a really wide range of different kinds of things. I think this is testament to this panel, really, is what are all the different potential ways that we could affect, society through use of machine learning. And I'll just highlight a few. So some of them have ties to South America. For example, HandTalk is a Brazilian sign language interpretation application. Rainforest Connection is US-based, but they install monitoring cell phone. They basically strap a cell phone to a tree. Actually, I have a picture of that. And with solar panels. And then they can monitor for the sounds of chainsaws to detect illegal deforestation, and then sort of get people to the scene more quickly. And there's HandTalk, so that's the Brazilian application. And finally, I think as we see all these potential applications, it's really important that we think about how do we want to apply sort of AI to different problems. And one of the things that we did last year was come out with a set of principles by which we think about using machine learning in our products, but we also made these public so that other people around the world who are thinking about this, other organizations, can look at the principles that we came up with as we think about, for any given use of machine learning, how should we be considering, does it uphold these principles or not? And I would point out that a lot of these areas are actually both active areas of research. So the state of the art that we know for how to eliminate bias in machine learning models is a moving target. We sort of continuously come up with new techniques, but our goal is to apply the best known techniques to anything that we do in this space while also continuing to advance things. And so just as a sample, we've published about 75 papers in the last year and a half or so in areas, research areas related to the ones that the AI principles call out. Okay, and with that, I'm going to conclude the little intro, which is basically that I think there's huge opportunities here. I think we'll get a taste of many other opportunities from the other speakers in the panel, and I'm looking forward to the panel discussion. Thank you.
So, questions from the audience?
Oh, sorry. I thought we were doing the panel. Here I am.
Hello. I have a concrete question. Hey, here.
Oh, sorry.
I have a concrete question. How can you submit ideas and proof of concept projects for this? For example, I have a project that identifies weapons and dangers, but I collected the data set myself and I label it. But I know that you guys have like the people and the data and the compute power. So how can I submit ideas or proof of concepts?
Right. So like the AI Impact Challenge that we ran last year is one way. So I don't know if we have plans to do that next year or the year after, but certainly something like that would be a good forum. The other thing that we do is we try to make sort of open source tools available for people to then take these ideas and push them forward on their own. So things like TensorFlow and other things like that can help with doing these kinds of deployments. And then sometimes there are Google researchers or others who are interested that I can work to help put you in contact with.
Okay, thank you.
Thank you.
Other questions?
Oh. Here I go again. I'm back. Sorry.
Okay, I think no more questions. So here's one. Yeah.
Hi, sir. I would like to know if Bolo is in Spanish.
Yes, we are working on launching a Spanish version. So the initial version was in Hindi, and we have an English version that we have launched, and we're also, I can't remember the timing, it's either launched or soon to launch in Spanish.
Thank you.
Yep.
We have time for two more questions.
I think if you search the web for Bolo Spanish, you might be able to find info.
So how do you usually decide on priorities for the projects? I'm sure you have like multiple projects for social good. How do you usually prioritize all of them?
Yeah, I mean, it's challenging because there are so many possible things we could do, and our researchers are sort of really excited about lots of different things. I mean, I think ultimately it's similar to how you prioritize research projects, which is you want to find things that are like going to be impactful, that are difficult, so that they can't really be done with current techniques or require some use of machine learning or other sort of technology to be brought into solving the problem. I think those are the ones we're sort of best suited to work on directly or to partner with people. And then really you're trying to assess, if we work on this, what is the population or community that will be affected by this? Sometimes that's hard to balance because you could work on something that can give, say people who have lost the ability to speak back their voice. And that's a really small number of people, but the impact of that for them is transformative. Or you could work on something that has a modest effect for 100 million people, like better flooding alerts. And it's sometimes hard to kind of manage and figure out the right metrics to use to weigh those different things, but you want to make sure that in your portfolio of work of this kind, you're working on what you believe to be a good set of important problems.
One more question there.
Hi, my question is, how do you manage, how do you work with the challenge of offering these types of applications to people that have low income and so they do not have almost access to internet or technology?
Yeah, I mean, this is actually one of the things that the Bolo team thought about pretty carefully. So it's basically a free application that you can put on your phone, and when you're actually running it, it requires no internet connectivity, which is an engineering challenge to get kind of the speech recognition models that you need to assess student proficiency and so on, running even on fairly low-end Android phones on device. But I mean, I think that's kind of the way you have to think about it, is how can you put yourselves in the shoes of someone who might want that thing but doesn't have a lot of disposable income to spend on that kind of technology. How can you make it affordable to them to get the benefits of it? And each project will be a bit different in how you sort of engineer things or make the trade-offs to get that to happen. Cool. Okay.
Okay, thank you very much,
Thank you.
Jeff. So give an applause to Jeff. Thanks.